So I'll go over now the system connection diagrams, which might be useful for you when you're connecting or designing your PV system. So I'll show you the system connection diagram for the EM and the ES, which is the low voltage single phase inverter. So on the left-hand side, as you can see, we have the battery terminal here, which is a set of terminal plates, which will allow you to screw the battery cables into that terminal. We do recommend, if the battery that you're using does not have an internal DC isolator or a DC breaker, then we do suggest that you install a external DC breaker. But there are regions around the world, regardless whether the battery does have an internal breaker, they do stipulate that you install an external DC breaker. So I would read your NEN rules to see what is a must or what is a must not have in terms of the DC connection. Also for the batteries, we do have a connection to the BMS terminal of the inverter. That's for the communication between the inverter and the battery. Moving along to the right, we do have the DC inputs. So for the ES inverter, we have 2 inputs, so one for each MPPT, and then you would connect your sub strings or your sub arrays to each input. When we're looking here at the AC output terminal, if you can remember from last week, if you were here, we have 2 outputs, AC outputs, one on the right hand side, which is the on-grid output. So this is where you will make your connection to the loads and to the grid itself. And then on the left-hand side, we have the backup output. So the backup output will be connected to your backup loads, your essential or critical loads. So in the case where the grid fails, the inverter will still provide power from the PV panels and the battery to your backup loads. So they must be run under a different circuit. Here in the middle there as well, we have a connection from the inverter to the smart meter as well. So the smart meter is measuring the export and import power that's coming in and out of the house. And with that information, the inverter is able to determine how much power to discharge or charge the batteries and how much power to stop exporting back into the grid, etc., etc. So that's just a high overview diagram of the EM and the ES. The ET and the EH is much the same. I won't go into it in detail. It's just a 3-phase high voltage inverter. So I guess one of the main physical differences is just the layout of the AC output of the inverter. So as you can see from here, the backup and the on-grid were side to side. However, with the ET and the EH and the BT for that matter, the on-grid terminals are on the top and the backup terminals are on the bottom here. So both the on-grid and the backup outputs are 3-phase. So you can spread your loads across each phase as you wish. Another difference is when you're using a 3-phase hybrid inverter, the smart meter that you receive will be connected to 3 CTs. So with a single phase, you will only have 1 CT, and with the 3-phase inverters, you will have 3 CTs to clamp around each phase. So going into it, for the PV array connection, most of you will already know how to strip and connect MC4 connectors onto a cable, so I don't really need to go too much in detail on how to connect the MC4 connectors. But what I will say is that make sure that you're using the correct MC4 crimping tools and make sure that you regularly calibrate them. So I think MC or multi-contact or the suppliers of those tools recommend after a certain amount of crimps, so after maybe 1,000 crimps, to send it to a company to recalibrate it. Or if you haven't reached 1,000 crimps, then an annual calibration will be effective. This is important because there is an IEC standard on crimping the pins onto the cable. So there is a particular profile and there is a particular amount of force that needs to be applied onto the cable to ensure that the crimping meets the IEC standard. So very neat to, well, very useful to know. So in terms of the battery connections for the EM and ES, this is a low voltage hybrid inverter. So typically with low voltages, we're talking about 48 volts, and the battery cables for low volt inverters and low volt battery banks are quite large. So we're looking at using conductor core sections between 20 and 35 millimeters squared. Because of the low voltage, that means we're actually generating, or the battery is discharging high amounts of current to meet the power requirements from the loads itself. So the lower the voltage, the higher the current that's being the higher the current that's flowing throughout the system. So here we give you a typical recommendations on how to strip the battery cables, and because the battery cables are quite large, the standard MC4s or the standard Sunclix Phoenix connectors, contact connectors, aren't large enough to crimp around these size cables. So this is why we do supply these battery terminals separate into the package of the inverter. So what you usually do is you strip your cable as per the previous slide, then slide on the screw caps and the waterproof rings, and then slide the cable into the battery cover that we supply in the package, and then crimp on the battery terminals that we also supply. So make sure you have the correct crimping tool to crimp on the lugs that we do supply with the inverter. So I think some installers also coat the crimps with some kind of spray over the top. But it's not really necessary. However, some installers do that. So I mean, anything that helps the integrity of the system is of a benefit to the installer and to the end user. So once you've done the crimping, then just using a small a standard screwdriver, terminate the positive and negative cables onto the battery terminal, and then screw the battery enclosure. So this battery cover here does have a seal along the side to maintain the IP65 rating. So just make sure that that seal is not damaged or hasn't been compromised. So in regards to the battery connection for the ET and EH, because it's a high voltage inverter, so we're talking about batteries which are, again, over 160, 180 volts. With these battery banks, because of the higher voltage, we are dealing with lower current. So the maximum battery current that we can use for our ET and EH is 25 amps. So this means that we can use a conductor size of 4 to 6 millimeters squared, which then allows us to use the Sunclix connectors, which is then supplied with the inverter. So if you're not familiar with the Phoenix contact Sunclix connectors, they're described as a toolless method of connecting DC cables into a PV system. So they are supplied with a spring clamp here. So all you have to do is strip the cable and insert the cable from one end and then push down. You can do it with your finger, or you can do it with a screwdriver. Just as soon as that cable is inside, then you can clamp down on the cable to ensure that the cable is securely terminated into that Sunclix connectors, and then you can screw the gland to ensure that the IP68 rating is maintained. One of the good things about the Sunclix connectors is that every time you push down this clamp, it actually meets that IEC standard that I was talking about with regards to crimping pins on DC cables. So one of the advantages with the Sunclix connectors is that this pin can be pushed down up to 9 times. So you have 9 chances. After the 9th time, then you will have to cut the cable, restrip it, and then use a new Sunclix connector to connect the cable to the connector. So it gives, with the MC4 connectors, if you do not do the crimping correct the first time, this means you have to throw away the connector, recut the cable, restrip the cable, and then redo the process. So every time you get it wrong, you're actually shortening the length of the cable. But with the Sunclix connector, you actually get 9 chances of getting it right. And then once you've connected the Sunclix connectors onto the battery cables, then you connect them onto the battery terminals of the inverter. So with the ET and EH, we do supply 2 types of connectors. So we do use the MC4 connectors for the PV side and the Sunclix for the battery side. So we differentiate them so there's no confusion, and to help with the identification of the cables when installing. So the AC connection of the EM and ES, very simple. We do recommend inside the manuals certain circuit breaker or the AC isolator specifications or ratings. So have a look at the manual. I'm just showing here the recommendations for the ES, for the 3648 and the 5048 inverter. Again, look at the rules, see and check. And then check locally or check what your regulations say on how to size your AC breaker specifications. But again, in the manuals, we do give a recommendation, but that is more sort of a global recommendation. But what I think is more important is to stick to your local regulations. If you happen to be installing multiple hybrid inverters, then each inverter should have its own AC breaker or own AC isolator, which is then paralleled into a main AC breaker or main AC isolator. If you're using an individual inverter, as you can see on the right-hand side, then it's sufficient to use one AC breaker on the AC output of the inverter itself. So the AC breaker is there as an isolating point and to protect the cable. So the AC breaker is not to protect any device within the system. It's mainly used to stop the cables from catching on fire. In the manuals, we do give you an outline on how to strip the single phase cables. Typically the earth cable is a little bit longer than the phase and the neutral cables, so just be aware of that. That's mainly just to ensure that you're able to connect the cables onto the terminal itself. So once you've connected the terminals, once you've stripped the cables, just feed them through, much similar to the battery cover. Ensure that you have the glands and the waterproof rings, and then feed the cables through. And then I would also recommend that you crimp on some bootlace ferrules, as we say in English. I'm not sure how you call them in Dutch, but this also helps with the termination into the terminal of the battery inverter or the hybrid inverter that we have here. So these types of connections aren't new to you. I'm sure you do it every day, so I don't really have to spend too much time on this. In terms of the battery connection for the, this is wrong. The AC connection for the ET and EH. Similar again, read the manuals for the AC isolator breaker specifications or current ratings. Similar type of do's and don'ts for this type of inverter. What I will say, the only difference between this and the single phase inverter is now that we're dealing with three phase or 3 active cables as opposed to 1 active cable. Again, look at our manuals to see what size or how you should strip them and the lengths that they should be cut to. Similar type of way of connecting into the inverter itself. And I guess one of the main aesthetic differences is that the battery cover is vertical as opposed to the ES and EM cover, which is installed at a horizontal. So just be aware of that. Again, I would recommend, or highly recommend, that you crimp on some bootlace lugs or ferrules as well to ensure a secure connection. So until now, we've done the PV, DC, and the battery DC and the AC connection into the inverter. Now what I'll do is take you through the battery compatibility, just to give you a summary or review of what we did last week, and then also go through the installation of a BYD battery bank to a hybrid inverter.